Hi and welcome back to the lab. Today here on the bench we have a AnyTone 588. So that is a VHF unit, and the VHF unit came in with the fault description that the ampage tested on the power supply is fluctuating. So the old man thinks that the output power is fluctuating as well. So let's have a look what's going on, and let's see what we can do. Okay, and here we have our AnyTone already connected, and it is running quite a while to get really on temperature. And what you can hear, it is receiving, so that is no problem. And now let's check a little bit what's going on with the output power and the current and what have we. Well, at the front desk examination, we did not see directly the problem with the fluctuating amps current. So I thought maybe it is a little bit depending on the temperature, and that's the reason why. So now let's start testing. Okay, so let's go right for the TX test. So radio set to maximum power, which is with units like this between 50 and 60 watt output power. And let's see what we get. And yeah, okay, so it's 21, so we clearly see that the output power is reduced. And what I can see on the other hand, that the current which is drawn is definitely too high. That is definitely a problem. Okay, and here we have a first look into our radio. And well, it is straightforward. So we have here our final stage. Under this shielding we have our driver stage, and well, this transistor down there, not sure if you can really see it down there, so that is a pre-driver. So yeah, all is straightforward, no problem whatsoever. But it is clear that well, something is wrong here. Well, and when we look here at our amp meter, we see that it is drawing 13 amps, and that is far too much for the radio, even on the highest power. Okay, and when we look here into our specifications, we can easily find that current drain on transmit is less than 10 amps, and we was testing for almost 13 amps, so that is definitely too much. And when I look into my notes, which I normally put always down when I'm working on radios, and in the past I have seen that those radios on full power, means approximately 60 watt output power, that we have 7.9 amps, 8.1, which I would call normal. Yeah, and here you can see what I've told you before. It is a 60 watt unit, so it is quite strong, no problem whatsoever. Okay, once again, if we really have 13, yeah, you can see it, 13, 12.9, 13 amps, but we have, as we have seen it, a reduced output power. So it is not 60 watt, what we would expect. It is only 20. So that is what we have seen just a couple of minutes ago. So higher power or higher amps, higher current, but less output power. So what does that mean? Well, one could think, okay, maybe we have a problem with our final stage. Is it broken? Or maybe our driver or even pre-driver is something wrong with, you know, one of these transistors? Maybe. But first of all, let's test our bias voltage, because that is really an interesting question. Okay, and some months ago, I don't know, I noticed that bias on the final should be around 2.5 volt. So that's the first what I'm really interested in. Okay, so we should be able to see all what we need. Let me go down to our gate, and of course there is nothing in receive. So let me double check. Do I still have here receive or not? Let me check. Yeah, we have still receive. That is fine, no problem. Yeah, okay. So okay, let me switch it down. Okay, and now let's go back here to the gate, and let me go into transmit, that we can see what we got. Whoa, 4.1 volt means that is 2 volt too much, and that would explain the excessive current draw on one hand, and on the other hand that would explain the reduced output power, because if we have too much bias, then of course the transistor can't really work as it should. Okay, so let's try to understand a little bit better our schematic. Let me zoom in here a little bit. So we see here our final stage, and you see it is mentioned here. So that is our final, and that is our pre-final, or our driver, whatever you want to call it. And what we see as well, let me see if we can get it into view. Yeah, should work. So we see that we have here our gate, and you see this way here over to 8 volt transmit. So 8 volt transmit comes over to our final, and should deliver approximately 2.5 volt here to this point. But we see that we have 4.5, and of course the question is, where does it come from? So if the 8 volt here is fine, well, it is very seldom that resistors go lower in resistance, so maybe sometimes they go higher. So that would mean we have a reduced gate voltage, but in our case we have a higher gate voltage. And well, the question is, how is that possible? So let's assume that our resistors are fine. I mean, we will double check here our 8 volt if everything is fine over there. But then, other than that, we should see only 2.5, and if there is something coming higher than 2.5 to the gate, maybe we have leakage here. Maybe our coupling capacitor here. I don't know. This is a totally unknown fault picture for me. I've not seen it before on this radio, I mean. So we get to our, what is it, to our driver. We get, okay, so that is a 6 volt, which we should see at the drain of our driver. And if there is for any reason a leakage here on our C374, then that would explain it. I mean, not sure that that is the problem, but it would explain, you know, the problem. Okay, when we look here into our, or if we look here at our PCB, we can easily find our coupling capacitor, and that is this guy here. So that is a ceramic type capacitor, which is going here over this 0 ohm resistor, so that is only a bridge to the gate of our final. And of course, if there's a problem in any way with this capacitor, I mean, it is a ceramic capacitor and they are known for that they break inside. So I mean, it would not really be something surprising us, but up to now we cannot be sure. So let us first test our 8 volt transmit, if that is given. Okay, so we should be able to see everything. Let me go down to the test point at the resistor, and of course on receive we have nothing, and yes, 7.8 volt, so there is nothing wrong. So for instance that we would have a higher voltage because of a broken transistor, whatever, voltage regulator, so everything is possible, but we see we have 7.8 volt, so that is exactly our expected 8 volt from the receive transmit switch. Okay, so the easiest way to see if it has something to do with the capacitor is that we simply take out here our bridge resistor, and if then we have our expected 2.5 volt present here at our gate, then we can be sure that we have a problem here. On the other hand, if we take it out, of course, we can test here, you know, this side of our capacitor, and if the capacitor is really leaking, then we would see a DC voltage here. In all other cases, if I've taken this resistor out, we should see really nothing here at this side of our ceramic capacitor. Okay, so our bridge resistor is off, and I'm now interested what is the voltage on our gate. So let me go over here to the gate and let us observe our voltmeter. Wow, that is really curious. I mean, we still have our 4.1 volt, which is, as we know, much too high. The little resistor is off, and I wonder where does this voltage come from? Okay, so what have we done? We have taken out the C3, the little bridge resistor which was in between, and we have seen that still our 4 point something volt is at the gate. Then to understand where our voltage is coming from, I've just taken out our 470 ohm resistor in order to disconnect here our gate totally from everything, right? And when I go down now and do exactly the same test, going to the gate and transmitting, so we see there is no voltage any longer. And when I go to the other side of our 470 ohm resistor, we have our 4.1 volt. So that means that totally unexpected, the voltage is coming over our supply line. The question is now, why is that so? Okay, so the question still is, why is it so? But I already made a little progress here on the board, and I'm a little bit already ahead, and we have to correct one consideration, because for a second we followed the wrong way. So let's talk about that. Okay, so we discussed that we get here our 8 volt transmit. Oh, let me enlarge it a little bit for you, and it is definitely easier what we are talking about. But now I'm lost. Oh my goodness. Okay, so here is our 8 volt transmit, where we were saying that we get here our voltage, our bias voltage, over to the gate, right? And we recognized when we took the little resistor in between, so we saw that still our 4 volt on the gate was present, so we removed here our 470 ohm resistor, and we recognized that okay, now there is no voltage on the gate any longer, but still here on the other side is our 4.1 volt. And so the question was, where does it voltage come from? But there was one little fault in our conclusion. So our 8 volt transmit does not come from here, since our R283 is not in circuit, and that is the reason why here we find no use. So that means we have here an interruption. So that means it does not come from here. But when we go over, and that is of course now the right way to understand our circuit, we have here our APC controller, and the APC controller is the automatic power control. Okay, so and the power control is the circuit finally which supplies our bias voltage, and you see it here. So we have here our final and here our drive, and you see that our operational amplifier from our APC is delivering our gate voltage to both the final and our driver, right? And of course we get here from our output stage. So when we go over, you find here, of course, where you cannot see it, sorry. We can see that we got here our antenna connected, so that is our output from our final stage, which we have here, of course. And when we follow along, we simply find here these diodes, and these diodes here are for monitoring the output. And a portion of our output goes here over our two diodes, come down here to the D2025, and you see over this little potentiometer we are feeding in here into this operational amplifier, which is in its first stage here nothing but an impedance converter, right? So that means what we get in here is what we get out on pin 1, and then we go over here our second amplifier, operational amplifier. So that is a dual pack operational amplifier, and then we get our gate voltage delivered, and depending on the output power we get finally the voltage towards our gate controlled. Okay, so on the other hand here on pin 5 of the second operational amplifier, we get our input. And that is the input what we get from our PC. You can't see it, sorry. So here we can see that our CPU or our MCU gets the information over to pin 5 of our APC controller, and that is literally high, mid or low output power. So that is let me say 5 volt, 20 volt or 25 volt and 60 not volt, sorry, watt. So that is the output power which gets adjusted here to our pin 5 of our APC controller. So that is how this circuit is working, and I found already this little potentiometer which is not working right, and that is most likely the problem, that we do not get a real control voltage, because if we don't get here the right voltage over our D225 and then over this little potentiometer to pin 3, of course our APC can't control the output power and holds the current constant. And we have seen that we have excessive current which gets drawn, and that is because our controller here is not able to control the output, and therefore it is always thinking, oh, we need to give more power, and then we come into an area where our amplifier does not really increases the output power, so we come to a point where it decreases because the whole system is not any longer in balance. And down here on the board you see already that I have connected here a little wire, because I have taken off our original potentiometer, which is in here, and I'm I'm 80% sure that we have a problem here with the potentiometer. But to make 100% sure that our operational amplifier is working, I've put here, you know, my little wire, and that is going to my power supply. And when I'm increasing here the voltage into our controller, then we should not see output power. So therefore I've set here, for instance, my power supply to 0.5 of a volt, and let me put it a little bit higher, let's say to a volt. And when we have a volt connected to our operational amplifier, then the output power, and that means our gate bias, gets dropped to low, simply to interrupt the amplifier amplifying. So that is how simple it works, and we can check if it works when we go into transmit in this configuration here. And when we don't see any output power with, you know, let's say 0.8 of a volt at the input of our APC controller, then we know that it seems to work, but it is not totally the right information, because we need then to drop, you know, the voltage under a level where it is switching to high, and our stage, our gate of our amplifier gets the bias in order to amplify the input signal. And that is what we want to check now. Okay, so at pin 5 of our amplifier, of our operational amplifier, so that is the APC controller, so we get the information from our processor telling the radio what the output power should be. So that is given. I've tested that, and with 0.8 of, you know, with 0.8 of a volt, we should not see any bias at our gate. So let me check that. Okay, so as you can see, I'm probing here at the gate, and let me go over to the meter. And as long we do not press here our PTT, we see 0, that is for sure. But now I press the PTT, so you hear that our receive tone is gone, and you see we have 1.7 millivolt at our gate, and we do not have no output power. Okay, so now let me go over to my power supply, and I'm pressing again now transmit. So radio is in transmit, and I'm reducing my voltage at the input of our APC controller. 0.9, 0.8, 0.7, 0.6, 0.5, and you see now we have gate. Okay? And when we have gate, let's see what our output power is. So I directly go over, as you can see, and now again, boom, 72 watt. And that is telling us that our APC controller, so that means finally here our operational amplifier down there is working as it should. So now we put in a new potentiometer, and we try to align it, and then if everything else is fine, our radio should work again without any problems. Okay, so I have here my SMD. Let me take here one out. Okay, so that are SMD precision potentiometers. So that is a 5K type, and that should be a good part to put in as replacement in order to get our APC controller back working and thus our right gate voltage. Okay, so now we have here replaced here our new potentiometer, and I've taken out a resistor because this is now a precision potentiometer, and I'm able to adjust it very accurate, and taking the resistor out helps a little bit to get more voltage here to our operational amplifier, where we know by the test we have done before that it is working fine. Okay, so let's have a look what have changed now. Okay, so let's have a look here to the output power. So radio is set to low, and that means around 10 watt output power. So let's see what we got, and you see 10.6 at 3.2 amps, which is fine. Okay, now let me set the radio to mid power, which should be around 20-25, something around that. Let's see, yeah, approximately 25 watt output power, and you see modulation is also working. So, and our approximately 25 watt is at 4.8 amps, which is fantastic. Now let's go over to full power, and I have reduced it a little bit. So you see it is 56. Now the radio is really hot, so I adjusted it to 55. So it is better to go a little bit lower, simply because we are reducing the ampage. So now we have 7.6 amps, and you see it is now very stable, right? So of course the power adjustment has been taken place by adjusting here our precision pot, because we are able to align the output power by changing here our voltage towards our APC, and that has been done. And let me go over to our power supply, and again it is set on high, and you see now we do not exceed 7.6 amp. And when we go now to what is it, mid, it is 4.8 at 25 watt, and when we go to low, which we have now, you see it at 3.2 amps at 10 watt output power. So you see the circuit is working fantastic, and that of course means let me do it that way, and that means that our radio is now working fine, so no problem whatsoever. And also here our power bars is going up when we switch now. Now it's full power, and you see when I switch to TX, full power bars. And if we go to mid, you see we have 3 bars here. So everything now is back stable and working absolutely fantastic without any problems. So that was a little bit tricky. but you see, that is how it goes, and I hope that was somewhat interesting for you, and hope you learned something. Catch you next time. Bye.